Alright, this is the video if you haven't studied for the extension exam. So basically, let's just start with it. We will go with our first question. This one, multiply both sides by 1 minus x whole squared to make sure it doesn't change the sign. 2x plus 1 minus x greater than or equal to 1 minus x whole squared, 1 minus x whole squared minus, never factorize this, that's dumb, move the left term to the right side, and then factorize from there. 2x plus 1 minus x is less than or equal to 0. 1 minus x, factorize that out. 1 minus x minus 2x minus 1, that's less than or equal to 0. 1 minus x is this, so 1's cancelled out, so we minus 3x less than or equal to 0. Now just take this minus sign, expand it. I don't know, it's just a bit simpler. 3x times x minus 1 looks more straightforward really that way. Now just draw a quick sketch. Intercept at 0 and 1, upwards facing parabola. Now it's asking when it's less than 0, that's 0. Just pretty simple, alright? Don't be stupid and you get it. Next question, x squared plus 4 over x, and that is all greater than or equal to 5. Now this side, you really can, you can split this into two fractions, so absolute value of x squared plus 4 over absolute value of x, but like, I don't like doing that. Squaring both sides, much simpler. X squared plus 4 whole squared. Now do a couple things at once. Square 25, 2 squared to 5 becomes 25. The x squared on the bottom is always going to be positive because it's squaring, and I'll just bring that to the top, so this will be 25x squared. Simple way. Move to the left side, x squared plus 4 whole squared minus 25x squared. Now think about it. Why do we do this? Factorizing difference of two squares, x squared plus 4 minus 5x whole squared, x squared plus 4 plus 5x. All right, we gotta make sure we add right. Many mistakes have been made because of that. Personal experience, ain't that right? X squared plus 5x plus 4 greater than or equal to 0. Factorize this again. This is minus oh my, I'm throwing, what is this? 4 minus 1 minus 4 minus 1 x minus 4. This is x plus 1 x plus 4 greater than or equal to 0. This is just a quartic. By now we should be able to know this, right? It's just simple. Draw this. We know it's always upward facing, just like this, and that's pretty much it. Now it's asking for when x greater than 0, so that's just the x-axis. We'll say x is less than, it should be -4, so -4, -1 x, and x is greater than or equal to 4, and that is our solution. Now we really should check the solution. Plugging this in, -4, we'll just plug in these end values. -4 squared, yes, seems about right. 4, yeah, seems about right. 1, yup, -1, yeah, seems about right, boys. Yeah. Next one, speed run through this. X plus 1 minus x minus 2 equal to 5. Solving this, we just take cases, let each equal to 0. The critical points will be, oh my, cannot spell today or anytime. Critical points would be -1 and 2. So we'll just say x is less than equal to, oh no, not always make sure it's, we make sure this is negative is less than, not equal to. We do that for the other domains. We make this domain. Now this will just be, this is always negative, so -x -1 minus, this is also -1, so just make this positive, x minus 2, that's equal to 5. So x cancel out, and that is -3 equals 5. That is obviously not true unless you're I don't know what you're doing, so that's no solution. And then we go to our next domain, which is -1 x. Now, like, I don't know about this, but I always put the greater than equal to sign on these domains, never on this one. I don't know why. Looks better. I don't care. So this will just plug in a number, 0, that's positive, minus. This would also be, this would actually make this negative. So we'll still keep it like that. So this is 2x minus 1 equals 5. X equals, what's this, 6, 3. Right? Hopefully I've not added wrong. But however, this is not in the domain. Our domain is between, we set this domain to -1 and 2, and our solution was 3. So this is no solution as well. Now we go to the last domain, which is x is greater than 2. We do this, x plus 1 is always positive, minus x plus 2 is also negative, so this will just be the same thing, is equal to 5. That's cancel, that's -1 is equal to 5. That's also no solution. So yeah, I should have made a better question for this, but yeah, as long as if you get a solution, it has to follow the domain as well, basically. And we keep going and calculate the range of this function. Now this is simply 1 over x. This would be 4 minus 2 plus 2, 2 minus 4. Now if you just graph this function, if you just graph the original function, we'll get at -2 and 4. I'll draw the original function in dotted lines, and we will draw the, okay, so this is the asymptote here, asymptote here. Oh, no way, I missed that, right? So that's 1, and we know it will be like this. This is another graph, and this will be like this. Roughly, the main point we need to figure out is this one, right? Over here, this is just going to be approaching 0. It's going to be approaching infinity. It's approaching 0, and this is also approaching -infinity. So we just need to find out this point. We find this point by reciprocating this vertex. The vertex of this function is that is just 1, the x value of 1. So you plug in 1. So 1 over 1 minus 2 minus 8. That is.
La la la. Bye bye.
Thank you for ruining that. That's just 1 over minus 10. That's just minus 1 over 9. And that means this y value is -1 on 9.
Screen recording?
What? I'm making a video. Shush.
You know that's gonna be in your video.
I know, just shush. This is -1 on 9, and that means our max here has a y value of -1 on 9. And plugging this, our range would be -infinity to -1 on 9. And this would be including, what am I doing? And this would continue from 0 to infinity. 0 is not counted because it's approaching 0. You guys should know that. And this is our final solution for this question. I don't know why it does that. Okay, next question, we'll find the domain of the square of this. Y equals 1 over square root x plus 7 plus 1 over absolute value of x minus 5. So this, you will get two separate inequalities. We'll just say x plus 7 is greater than, now it cannot be equal to 0, right? And absolute value of x minus 5 cannot be equal to 0 as well. So absolute value of x is not equal to 5. So x can't equal to plus minus 5. For this, we just say x has to be greater than -7. And yeah, that's pretty much it. So if we put this in interval notation, we would get, so between -7, so we'll start here, domain -7 to, we'll say -5, and then continue again, -5 to +5, continue again, 5 to infinity. Or, oh my, if you want to see this in normal, just in a what's this called, freaking, yeah, the inequality way, you would just say x has to be greater than -7, but x cannot be equal to plus minus 5. Simple as that. And we're coming to an end, really. That's unlucky. Nah, but it's a surprise at the end. This, again, mainly just squaring x minus 3 whole squared, where it's less than equal to 2x minus 1 whole squared. Now, when you're squaring this, x squared minus 6x plus 9 less than equal to 4x squared minus 4x plus 1, 4x squared minus x, what am I doing, bro? 3x squared plus 2x minus 8. Couldn't have picked uglier numbers for this. Could factorize, could not. What's this? 4, 2. Got him. Yep. That's right, right? Yeah. If it's not right, you guys can deal with that. I don't care. X plus 2 greater than equal to 0. Now that means our intercepts are at 4 on 3, roughly here, and -2. Upwards facing, just like this. We will say x is less than -2, x is greater than 4 on 3. I think this is right. I think I factored it right. I'm moving to the next question. And we have the graph. Pretty weird debate. So we can just finish this. And so this is just simply at -7, and this should be at 5. It's a double root here. And that's pretty much it. And it's a cubic going from this general direction. We know it's single root here, double root here. Just a rough sketch. This is a really bad sketch. Wow. And I forgot to find the y-intercept, of course. That is 2 times 7, 5 squared, 25, 50. What's 50 times 7? Have to check this now. 350. Yeah, this looks like a 350. Scaling a bit whack, but yeah, seems about right. Now, our next question. So, our new, you have to find the equation which satisfies all these parameters. Now, with roots, you always want to put, if it gives you roots and just nothing else, then you just want to put a, because it's like a multiplier. Now, it's x minus a, where a is the root, so it's just x plus 4, x plus 3, x minus 2, y equals. Now, they give you a point for this reason. The information that they give you is not for any reason. They're gonna give you they're gonna give you the information for a reason. So this is mainly to find out this point right here, this a value, because it's a multiplier. Mainly, like, if you were just looking at this as an example, this would be -4, -3, and 2. This graph could look like this, or it could look like this. You get the idea. Like, it can have many different y values depending on what the multiplier of a is at the front. So we want to make sure we find that using the y-intercept that they give us. We'll say -96 equals a times 4, 3, -2. -96 equals -24a. Finding out the value of a, 96, -96 over -24, which is a equals 4. Meaning y equals 4 times x plus 4, x plus 3, x minus 2. And that I think is the last question.